So what if you were told in just a few days, weeks, or months, or even years, that an asteroid big enough to resurface the planet was going to hit Earth, killing you and every other thing on it? We're essentially stuck on a rock, orbiting a nuclear furnace in a shooting gallery. Understanding this, for me, has caused me to be really interested in how we might be able to escape the Earth and travel to other habitable places. There are three main columns that you need to consider when even attempting to build a ship that's going to take you to other planets. One is the dangers of space. Two is traveling at speeds fast enough to get to other places in a timely manner. And three is finding a habitable planet. Space is an extremely dangerous place. As stated in Robots in Space by Roger D. Lanus and Howard E. McCurdy, every civilization is obliged to become spacefaring, not for the romantic zeal of exploration, but for the most practical reason possible: survival. So the first thing we must consider is the lack of protection in space. On Earth, we're protected by the magnetosphere from the sun's harmful rays, and it also protects us from meteorites and cosmic rays from just the universe all around, because all of these stars are also sending out dangerous rays. Micrometeorites travel at tens of thousands of miles an hour, and any spacecraft traveling at, say, even a fraction of the speed of light is going to add an extreme amount of energy to an object like that. So after you overcome the dangers of electromagnetism or the violent rays from stars, cosmic rays, and the dangers of micrometeorites and black holes as well, which can be extremely massive and small, and you can't see them because they don't emit any light, you have to consider the size of space. Space is a very big place. As stated by Richard F. Tender in Relativistic Flight Mechanics, is interstellar space travel impossible? An honest answer, no. But interstellar space travel to even the nearest star cannot be done with current technology. Stars are so far away that we measure the distances in light years, and that's the amount of time it takes for light to travel in a year. Light travels at 186,286 miles per second. That's fast enough to wrap around the Earth 7 times in 1 second. At that speed, it would take at least 5 years to get to the nearest star. And that's if we don't actually consider slowing down. That's if you're just traveling at the speed of light. So any ship is realistically going to have to slow down. It's probably going to take twice that time, at least. So any spacecraft, of course, that's going to get us to other star systems is going to have to go at least the speed of light, if not beyond the speed of light, on some sort of warp drive, which might be beyond the laws of physics. So once we've protected our spacecraft and we've accelerated it to near the speed of light, at the speed of light, or maybe beyond it, we have to consider a third problem, and that's where do we go? As Bruce Dormany states in Distant Wanderers, I've been astounded not just by the frenetic pace of discovery, but by the mind-boggling variety of what astronomers have found. So there are around 400 billion stars in the Milky Way galaxy alone. And there's about 150 billion galaxies in the universe. There's lots of places to go, but it doesn't mean that they're all habitable. Everything in the inner part of the Milky Way galaxy, there's too much radiation for there to be any viable places for us to go to. So we can concentrate our travels on the outer part of the galaxy, but you still have 200 billion different star systems to choose from when you're doing that. Exacerbating the problem is that it's difficult to even see other planets because planets don't emit any light. They don't shine like a star. The only light you're going to see from a planet is what's reflected from the star. And just like trying to see a candle behind a spotlight, you're not going to be able to see the light from the candle. You're just going to be outshined by the star's light. So we can't see it, and at best we may be able to detect what kind of chemicals are at other planets, but most of the universe is made of hydrogen and helium, so you may be able to detect organic chemicals and things like that, but that's not really going to tell you if the planet's viable. Because, of course, even our own solar system is made of mostly those chemicals, and most of the planets in it aren't. We can't live on those. So energy becomes an issue when traveling between star systems as well. If you're going at high speeds, you need to generate enough energy to go at those speeds. And we don't have any technology that can continuously drive us at near the speed of light, so we're going to need to collect energy somehow. So I think the most probable scenario will be a ship that uses low energy while keeping humans in suspended animation, or maybe carrying our DNA, while it searches with high-tech sensors to find habitable planets. But of course, nobody wants to travel around to sleep. We want to travel around in a ship like this, where we get to talk to aliens and look at stuff and do cool things. And so the only way we're going to be able to do that is by designing a ship that confronts the three major dangers or the three problems that I put forth. One is the dangers in space, the cosmic rays and the micrometeorites, the size of space, the distances we have to travel, so we've got to go fast enough, and we need to find out where to go. But one thing's for sure, if we want to propagate our species, we have to get off of the Earth, or else we definitely will go extinct.